welcome to Two Projects. In this video, we are going to discuss about the project which is a recurrent approach for uninterrupted tracking of rotor blades using Kalman filter. So before getting into the execution, let us understand what is the project about. So what are the sources of electricity that we all know? We all know we use water for generating electricity. We also use coal, oil as well as wind energy. So here, wind energy, it is really important for making our power sources more eco-friendly. So this wind energy, by using this wind energy, we will not harm the environment. We will use all the sources in eco-friendly manner. But these coal and oil, they run out and they even cause the pollution. So we call this wind energy as renewable and it will not harm the environment. So using more wind power means we rely less on the fuels like coal, which helps us fighting climate change by reducing greenhouse gas emissions. So now coming to the next part, which is how is this wind energy generated? The primary infrastructure used for generating wind energy is wind turbines. So these wind turbines, they are typically installed in groups and they are known as wind farms, where they harness the kinetic energy of the wind to generate this electricity. And this generated electricity is then transmitted to the power grid through electrical cables for distribution to the customers, that is, consumers of electricity. And the problem here is not only using these turbines is important to generate wind energy, and it is also important to oversee these wind turbines and their rotor blades because it is essential to ensure their optimal performance and safety. But it is a big job because these turbines are really tall and spread out. Usually, technicians have to climb up to look at them, which takes a lot of time and it is very dangerous. So, to address these challenges in wind turbine inspection, we should focus on implementing advanced technologies. So, what are we going to do in this project is we use some deep learning algorithms called YOLO and develop an efficient system that will accurately detect this rotor blades efficiency. So, here we use UAV turbine images to detect the rotor blades. To detect this rotor blades, the author in the base paper he introduces an advanced system for tracking wind turbine blades using integrated AI techniques. He has combined squeeze and excitation network along with YOLO V5, which is an popular object detection algorithm to improve the accuracy and robustness of rotor blade detection. Additionally, they also used long short-term memory along with Kalman filter algorithm to ensure that continuous tracking even when blades move in and out of the camera's view. So to further enhance the performance as the extension, we have proposed YOLO V5XX, which is the extended version of the YOLO V5 with increased depth and complexity, allowing for more precise detection and tracking of wind turbine blades. This upgrade aims to achieve greater efficiency and reliability in wind turbine inspection and maintenance by improving the accuracy and robustness in identifying rotor blades. So, in this project, we follow a step by step approach. First, we explore the dataset by looking at the images and doing some basic pre processing. So, first, we explore the dataset and then do pre processing. And then, we use a pre trained YOLO V5 model to help us detecting objects in the images. And we also make some adjustments to the images to improve model's performance. After that, we train all the versions of the YOLO V5 model to see which one works best for our task. Alongside, we set up a user authentication system using Flask and SQLite for our application. When users upload images, our trained model goes to work identifying objects and showing them with the bounding boxes of the detected objects. This approach makes sure that we understood our data and we train our model very well and have a user-friendly system in place for object detection. So from all the versions built, YOLO V5X6, it performed well, so it is deployed it in the front end. Moving on, to implement this project, we need software and hardware requirements. So coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So moving on to the hardware requirements, we need Windows operating system, processor i5 and above, 8 GB and above RAM, 25 GB and above hard disk. These are the various versions of the YOLO which are built in the project. So first we will understand what is this YOLO. YOLO, it stands for You Only Look Once. And it is the state of the art object detection algorithm that process images in real time, providing a fast and efficient method for identifying objects within them. And it operates by dividing the input image into a grid and predicts bounding boxes and class probabilities directly from this grid. Unlike traditional object detection methods that require multiple passes over an image, this YOLO performs detection in just a single pass, directly predicting bounding boxes and class probabilities for multiple images simultaneously. This approach makes YOLO particularly well suited for applications requiring real time processing. Although all versions of the YOLO have similar objectives, they differ in their architectures. So, moving on to the YOLO V8, it introduces several architectural refinements, including a revamped backbone network, path aggregation neck for better feature fusion, and focus laws for addressing class imbalance. The next version is YOLO V5X6. It is presumably a larger and more complex version of YOLO V5, potentially with 6 detection heads for increased accuracy. The next one is YOLO V5SE. It incorporates squeeze and excitation blocks for improved feature extraction efficiency in YOLO V5 architecture. The last one is YOLO V5S. It is the smallest and fastest YOLO V5 model designed for balancing performance and resource usage. So, among all these models, YOLO V5X6 is performing well, which we have proposed as an extension. So, we are going to deploy it in the front end. So, to execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project which contains source code files. So, let's understand each file. How will they be used in the project? So here in the YOLO V5 folder, we have the data set. So there are two subfolders, one is train and the other one is test. In train, we have two subfolders that are images and labels. In images, we have images of wind turbines. So we use all these images to train all the versions of the YOLO. So now get back. Here in the labels folder, we have files containing annotations and the labels for objects in corresponding images. So each file it corresponds to an image file in the image folder. So this file it corresponds to this first image in the images folder, and the second file in the labels folder it corresponds to second image in the images folder. So these label files they provide details about object locations and classes within the image. So here in the images folder we have 322 images. Similarly, we have 322 files that are label files in label folder, which corresponds to image folder. So these label files, they follow the YOLO format where each line represents a detected object. I'll show you a sample. So I'm opening the first file. Here, each line represents a detected object. So in each line, it specifies one object class index followed by its bounding box coordinates which are normalized to image dimensions. So these are the bounding box coordinates of class 1 where this is the x limit, this is the y limit and this is the width and this is height. As this label file which corresponds to image file has 9 objects in it, so here we have 9 objects along with their bounding box coordinates. Here we have three different classes which are 0, 1 and 2 which maps to root, top and middle in the image. And these are the different classes that will be detected in the front end. So now close this, get back. Similarly, we have in test folder also. See here we can see images folder as well as labels folder. We use train folder to train all the algorithms and we use test folder to evaluate all the models to see how well the models perform. So now get back. Here in the YOLO V8 folder also we have the same images but with different annotations. Because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. Having separate folders helps keeping the dataset organized and ensures that each YOLO version receives the correct annotations it needs to function properly. Here in the sample folder, we have the images. So we use all of these images, which are test cases, to test how the model is performing. So get back. So moving on to the static folder, this folder contains files related to CSS, JavaScript, and Bootstrap files. They are important for project styling and interactivity. Moving on to the templates folder, here lies all the HTML pages utilized in the project. They are index.html, about.html, etc. And each HTML file represent a different page of the website and provide the structure and layout for displaying content to the users. And this is app.py file. This Python file encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be used to be presented in HTML templates. And this is the model file which contain the algorithm information and that will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. And this is the model file. Now we need to copy the path of the address bar from the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path of the code folder. Now click on enter. This will change current directory to the code folder's path. Here we can observe current directory is changed to the code folder's path. Now we need to compile app.py file. So give the command python space app.py and then click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running app.py file, Flash framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So now we need to copy this local link provided by the framework. So I'm copying the link and paste it in any web browser. I prefer Google Chrome, so I will paste it in that. Here we need to paste the link and then click on enter. So this is the web page of the project, which is displayed in the browser. And this web page is developed by using Flash framework. So first we have to sign up. Click on sign up link and enter all the registration details if you are registering newly. I have already registered and I have an account in it. So I will directly log in. So click on login. Provide username and the password. So I'm giving my username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page. So here we can see a choose file button. We need to click on that for uploading wind turbine images. So click on choose file. So these are the test cases in sample folder, which I have mentioned you already. So from these images, first we'll upload the first image and click on open. So here we can observe that image has been loaded. Now click on upload. From the image, we can observe that from the router blade, root is detected with 0.74 probability score and a pink color bounding box is drawn around it. Here, probability score is nothing but it is just a confidence level that how accurate the detection is. So now get back, click on choose file to upload some more images. So this time we'll be uploading this image. Click on open. Image is loaded. Now upload it. Here we can observe that there are multiple objects detected in the router blade that are top. So here we can observe there are 3 tops detected with the orange color bounding box. 2 middle are detected with the red color bounding box. and one root detected with the pink color bounding box. So now we will try uploading some more images and see the detection. So get back, click on choose file. This time we'll be uploading the last image. Click on open. Image is loaded. Now upload it. From the image, we can observe that application has detected multiple objects that are top, middle, root. So here we can observe 5 middle objects are detected and 5 top objects are detected and 1 root is detected with their respective colors. So we will upload some more images, get back, click on choose file. So this time we'll be uploading this image. Here we can observe there are 2 middles detected and 2 tops detected and 1 root detected and with their probability scores with their class labels. So get back. Now we will upload one more image. Click on choose file. This time we'll be uploading this image. Click on open and now upload it. So here we can observe there are multiple objects detected. So there are multiple roots detected in multiple turbines and also multiple tops are also detected in multiple turbines. So get back. Now we will try using some Google images. So go to the new tab, search for wind turbine images. So we will save this image. So save it. Now we will upload the image. Click on choose file. As we have saved this image, now we will upload it. Click on open. So as the image is not in JPEG format, so we have to upload only the images which are in JPEG format. So we will search for them. So we will download this image. This is also not in JPEG format, so close it. We will try using this image. So this is in JPG format. Now save it. Go to the web application, click on choose file. So as we have saved this image, now click on open. Image is loaded. Now upload it. So here we can observe that there are 2 tops detected and 1 root detected. So now we will see some more images in the Google. So get back to the Google. This time we'll be saving this image. Click on save. Get back to the application. Click on choose file. So as we have saved this image, click on open. Image is loaded. Now upload it. So here we can observe that there are multiple objects detected that are top, middle, root, along with their bounding boxes and different color bounding boxes. So now get back. We'll search for one more image. So now we'll be saving this image. It is not clear, so we will search for some other image. We'll save this image, save it, get back to the application, click on choose file. So this is the saved image. Click on open and now upload it. So here we can observe that there are multiple objects detected with their respective bounding boxes and probability scores and classes. So get back. In this way, just by uploading wind turbines to the system, it will detect the objects. So now we will see the graphs of the project. So click on graph link. Here we have the precision and recall graph of YOLO. Here on x-axis we have recall score and on y-axis we have precision. So moving on, this is F1 score graph of YOLO, which is F1 confidence curve graph. And here we have confusion matrix of YOLO. This is precision score comparison graph, where on x-axis we have precision score of each algorithm and on y-axis we have algorithm names. Moving on, this is recall comparison graph and this is MAP comparison graph. So now click on sign out. Through the extension of YOLO V5X6, an enhanced version of the YOLO V5 with increased depth and complexity, it signified a notable step forward in wind turbine inspection and maintenance, facilitating more precise detection and tracking of rotor blades.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.